Hey kids, welcome to another 5th grade math video for Eureka Math. This is for Module 2, Lesson 2 homework, and the objective today is to estimate multi-digit products by rounding factors to a basic fact and then using place value patterns. Again, everything we do is going to connect to place value, so admit that you're good at it and just jump right in. So here we go. We're going to round the factors to estimate the products. A couple of kids have said, well, can't I just do the actual multiplication and then just round the answer? And I'm like, why? Why would you want to do all that work to have this big, complicated math problem when we don't have to work that hard? So estimating is all about making your life easy. So sometimes kids love it so much they forget to actually go back and do the real math when we don't have the little wiggly equal signs. But we actually have to round for today, so we will not be doing the fun and complicated standard algorithm with multi-digit multiplication. So let's jump in rounding our factors. First of all, they're not telling you what place value position to round to, so you get to make them as easy as possible. We're going to start by going to the nearest 100 for this one, which would be 700. See, it's only 3 digits away. And the nearest 10 for this one. And what I want to do is I want to just make something where I have this basic fact, which is in the objective, get that basic fact, so that you can then multiply the 8 times the 7 and get 56, and then deal with the counting the zeros, shifting them over, the 10 times 100 that comes with all the rest of the problem. So again, I've said in previous videos, when you're multiplying with tens, hundreds, thousands, and all that, you just count the zeros. Each zero represents a place value position, so count them. It's so easy. 1, 2, 3. On the whole numbers, 1, 2, 3. Put your comma in, and that's literally your answer. That's as easy as we can make this problem. And so they're just saying, hey, if you do round the factors, you could say a reasonable estimate for this same problem, it's not a new problem, is this. We're just rewriting it, 56,000. They love to do things twice in this book. So here we're going to do it again. This time instead of hundreds, we have thousands. So you have to look at, here I was looking at like the 69 going to 7. Here I'm just going to, again, put that box around and say, I just want to get close to the 58, 59, but 59 is so close. This time, instead of having to have like an exact number like 59, we're just going to round it right up to 6,000. I don't want to have anything where I might have regrouping. I want to make it so easy with just round numbers. I want to have single digit facts. Okay, so you don't have to use the box method. You're just really trying to focus on the first part of the number and get it pretty close. Okay, so we start out with 6,000, and again, we've got a 2-digit, 67, pretty close to 70. That's good enough. 6 times 7 is 42. Count your zeros, 1, 2, 3, and 4. 1, 2, 3, 4. Don't put your comma in until you know that you have 1, 2, 3, 1, 2, 3, and then you can place your comma. Next one, a reasonable estimate. Oh, write the number again. We love to do everything twice. Let's do this one. Okay, 88, pretty close to 9. Instead of 8,840, let's just use 9,000. Now 45, this is when they start to go, oh, well, if you think this is easy, 82 going to 80. If you think this is easy, 67 going to 70. How about 45? What do you want to do with 45? Now, some students, okay, first of all, I have to tell you a secret. In the answer key, it will say on this, answers may vary, and that means that different students will have different answers based on what they choose to do. A lot of people will say, go up. Some kids will say, well, I just went down. And so eventually we're going to try to narrow things down to the best answer. But for now, for today, your teachers will have to say, yes, both of these answers would be correct. So if I have my 5, and this can be the either 50 or 40, either one is fine. Technically, if you really want to stick with the book, you would say, okay, well, 50 is more correct than 40, and that's true. But again, the math geniuses who started this just picked the random, well, let's just roll everything up, and 5 is exactly in the middle between 40 and 50. So it's equally close to go down as it is to go up. Anyhow, 9 times 5, 45. Same number of zeros, 1, 2, 3, 4. And then 9 times 4, 36. Same number of zeros, 1, 2, 3, 4. 1, 2, 3, 4. So both of these answers technically are correct for today because 5 is in the middle. A reasonable estimate could be, and you wouldn't want to go like to the middle, so I'm just going to pick one, plop that down there so I don't have to do this one twice. So complete your table using your understanding of place value, because we love place value, and your knowledge of rounding to estimate the product. So we've got 3 different boxes. Here are the expressions. These are all expressions. An expression is it's all set up to solve, but there's no equal sign and there's no answer. The rounded factors are what we're going to change these into so that we can then get a very easy answer. Today is all about making things easy. So if I have this big giant number with 5 digits, I don't really want it to be that big. I really just want a single digit in the front. Like I'm going to use the 8 and I'm going to drop everything else off because the 2 is a little number. So I'm going to go roll down to the 80 instead of 82. 1,000. Okay, so everything else becomes a 0. 240, I'm going to change that to a 200 because 4 is lower, and so I'm going to use 200. Taking the 8 and the 2, I'm going to have a 16 for my product, and then I have to calculate all these zeros. 1, 2, 3, 4, 5, 6. Put them all in. 1, 2, 3, 4, 5, 6. And now you get to put your commas in. 1, 2, 3, 1, 2, 3. It's like doing a dance. Okay? Every 3 places you have a comma. That's a new period. If you want to know what those are, go back to my beginning of the year videos. Okay, this one, notice that we have a 98. So technically, if I have 8 and I do a +1, I will end up not with a 4-digit number, but a 5-digit number. 9,832 would be closer to 10,000. So I can use this as my new factor instead of this one. Times 39, nah, let's use 40. Here, because I have added a place value position with this 0, I now have a 1 times 4 for 4, but use all the zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Put your comma in every 3 places. Got to really pay attention today because we have a lot of zeros. Here is unit form. Don't you love this? Unit form, great. What do we do with this? Well, instead of writing it in unit form, take it down below here and say what the number actually is before we round it. 98 tens would be 980. And 36 tens would be 360. Because remember, tens means we're bumping it over to finish in the tens place. Now, I don't really want to use these numbers here. I would like to use something that's a little easier. So 980 is pretty close to 1,000. And 360 is sort of close to 400. Again, just try to have the same number of place value positions. And then you can multiply 1 times 4 for the 4 again. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Same answer as above. Just looks a whole lot different going in. Okay, now this one has hundreds. How many hundreds? 893 hundreds, which means it's 89,300. Times what? 85 tens? 85 tens. But these numbers are big and awkward, and we don't like them. And so we want to make them easier. Instead of 89,000, why don't we just use 90,000? Same number of digits, 5 places, but it only has a single digit that I have to calculate with. 850 has that 5 in the middle, that pesky 5. So which way do you want to go? Most kids will say, let's round up. So we can. What if you went down to 800? Whatever. We'll let you do what you want. 9 times 9 is 81. Count the zeros. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Put your commas in every 3 places, and you should end up with 81 million. So these are kind of fun. I know everybody really likes these, but just when you get the hang of it, it's time to change up. The estimated answer to a multiplication problem is 800,000. So that's the estimated answer. Which of the following expressions could result in this answer? Explain how you know. And so when you have these, you want to kind of look at the place value positions. Okay? You don't actually have to sit there and solve, but let's start out by doing that so you can see what I'm talking about. If you have 8,000 here and 10 here, and I'm just, again, rounding to pretty close, then my total number of zeros, 1, 2, 3, 4, this has 1, 2, 3, 4, 5. So I can tell right away that this is too small because it only has 4 zeros. Okay, let's try another one. What if I was to round this and this? So that, again, I'm dropping that down, and this one only has a 1 and a 2, small number, so I just use the 100 there. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. This one is too big. This one has 6 zeros. And I really just need 5. So how about this one? If I have about 8,000, and then I have about 100, 8 times 1 is 8, and then I have 1, 2, 3, 4, 5 zeros. So if I have my 8 and my 5 zeros, this one would be just right. So 5 zeros is just right. Okay, so you want to kind of say why. That's the whole point, is to explain that you understand. This one here, we've got our big 80,000 again. And you can kind of guess, if I am starting with a bigger factor here and a bigger factor here, this is going to be way too big. Okay, because both factors are larger. Both factors are larger. Okay, so you're just kind of saying, hey, now I really understand about place value and how those zeros take up a place value position. Turn the page, and on the back we have a new activity. Fill in the blank with the missing estimate. Here is when you have to really start thinking about what your factors are that you're using to get that. Your answer, your product, is going to be really important here. So I can't use, say, 700 times 30, because I'm going to end up with 21, and that is not equal to 24. So you have to force your factors to be the correct numbers, okay? So force them in. So 751, of course, wouldn't go down to 700. It would more likely go to 800. And 34 would very likely go to 30, and that makes good sense because my 8 times 3 needs to be 24. And 1, 2, 3 gives me the proper number of zeros. On the next one, if I like the 6 here, and I look at this 6 and the 67, and I say it's probably going to be 700, double check that your product will be the product of 6 and 7. So yes, it will be. So I can use 600 and 700 to get the 42. And 1, 2, 3, 4. Yep, 1, 2, 3, 4. So those are good estimates. For this one, we would use approximately 8,000. That's really good. And this one's really close to the middle. So what would I multiply 8 with to get? Is it 4? No, it's 40. So I would multiply it and get 5. So I'm going to roll this one up to 8,000 and down to 500. Here's my 8 and 5 to get the 40. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so that's how you do those. You want to make sense of your product with your estimated factors there. Okay, for number 5, in a single season, the New York Yankees sell an average of 42,362 tickets for each of their 81 home games. About how many tickets do they sell for an entire season of home games? It's nice when they say about, because then you don't actually have to do 42,362 per game times 81. That would be a lot. So take your 42,000 and turn it into roughly 40,000. and take your 81 and turn it into 80. And now we have a very simple 4 times 8 for 32, and count the zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. About how many tickets do they sell for the season? They sell about, don't forget the about, 3,200,000 tickets in a season. I do hope these videos are helping you with your homework, but remember, always try your best before you use these. Otherwise, you're not going to be learning as well if you're just copying it. Although, please do try to listen and learn and tell your parents about this stuff that you're learning so that you can prove that you know it. That's really a good way to prove that you're learning, is to talk about it. Talk about it and share it. So click subscribe, come back again. Okay, Raphael wants to buy a new car. He needs a down payment of $3,000. Kids, if you don't know what a down payment is, it's a one-time payment that you make in the beginning before you make your monthly payments that are smaller. So he needs a down payment of $3,000. If he saves $340 each month, about how many months will it take him to save the down payment? So the goal is to get this $3,000. This is the goal, okay? But how many months, how many times does he have to save? Approximately 340. So if he's doing the 340, dot, 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 how many times, 1, 2, and so on, how many times does he have to save that amount? And so since we're talking about estimates, we can take the 3,000 and then break that up by the approximate smaller amounts. So we're going to use our rounded amount of 300. And if you were to say divide our total amount by approximately how much he would save each month, then our problem becomes a little bit more simple. You haven't really done a lot of large division with 300 or multiple digit divisors yet at this point. And so when you set this up, you might go, well, I'm not really sure how to do that. But, while I turn the lights on, but what you can do is you can also turn this around. Remember, when we do division, and we've worked on this for a couple lessons, it's really what it would go up here times this to get this. So turn it around and say 300 times what would give me 3,000. And so we're tying it in. Remember, multiplication and division are so closely connected. You should be able to see now that we just need to get 10 times greater to add that extra zero in that place value position. That's really the goal of this. It's not to do this division, although you could if you wanted to. It's to see that the extra place value position to get that 10 would make this 3,000. So 300 times 10 would give you 3,000. So you would say about 10 months. And that's really all you have to do for that one. You don't have to actually solve the whole thing. Remember, we're just estimating today, so yay. His new car payment will be $288 each month for 5 years. That's actually pretty cheap. So what is the total of these payments? All right, so what's the total? And we've got the $288 each month for 5 years. How many months is 5 years? We have to start out by figuring that out. How many months are in a year? That's one of those hidden questions that you have to know. There are 12 months in a year. And so we've got to do the 5 years. So it's 12 months times 5 to get 60 months. Okay, so it's going to be $288 for 5 years. In my book here, this one I think is older. I think in your book, it's going to say estimate, not what is, but estimate the total of these payments, because I think they have a typo in my old books, but in the new books, this whole lesson is about estimating, so I'm just going to go with the estimated total because I'm pretty sure that's what the kids have now. So if his new car payment is about 200 or 288, that's about 300. So remember, we're estimating, and I've got my nice quick fact here. So it's going to be the 60 months times about $300 for our estimate. We've got our nice simple fact here. 6 times 3 is 18. We've got a 0 from that one and 2 zeros from that one. And so the final total of the payments, all payments, would be about $18,000. Not a bad price. But if you could still get a car for that, that would be super. Anyway, thanks for watching, and come back again, click subscribe, and have a great day. Bye for now.